Okay, so we're going to record this lesson for anybody who is out there watching. You can simply just go to your, just type in Google Sheets and just grab a blank sheet. You can save this sheet if you want to. I'm going to call mine Statistics Regression Problems. And down here, I'm going to rename mine, my tab. I'm going to call this one Heat and Cost. You sure can. So you can see I renamed a tab called Heat and Cost. I can continue to just add more tabs if I want to and create more opportunities to do problems, but I'm just going to do one problem per tab. Notice that the problem in front of us says as follows. Let's see if I can find it. I think it's here. It says use the data relating the average temperature in a month to the heating bill at Claire's house that month. So you can see yesterday we talked about temperature and the heating bill. Temperature causes the heating bill. It says make a scatter plot of the data using the mean temperature as the independent variable. So we're going to make a little chart here. I'm going to go back to my spot here. I'm going to call it mean temperature and heating bill. So I've got my two variables, and then I just have to enter the data. So you guys have the paper in front of you, correct? Could somebody read off the X values for me when I get back to my sheet? Could somebody read off the X values? 38, 42, 44, 36, 42, 49, 38, and that's it. If you want to, you can obviously select a column or something of that sort. And you can center the data if you want to make it look a little bit nicer. So that's my X variable. I'm going to plot it against the Y variable. Aiden, would you be so kind to read off the Y values as well? 93, 79, 75, 83, 74, 67, 86. So there we have our data. I'm going to pause to make sure everybody is caught up with entering the data. Okay, here we go. So I want to create a scatter plot of this. So I'm going to grab the data. Anybody want to guess where I go to insert a chart? Insert chart. And notice it knew to grab a scatter chart right away. I'm going to click out of that so I can see the chart. The chart is rather large. I feel like it's too large. I'm going to resize it and try to fit it into a more reasonable area. Let's look at the data. Do you think that there's a trend that exists? Could you draw a line through the data there? Yeah, you could. You maybe want more data points or something like that, but you could definitely draw the data. You can highlight these and see the different values, make sure that they're consistent. And so we've done the first part, which is create a scatter plot. Let's go to our next problem here and see what they now ask us. It says find the correlation coefficient and the equation of the best fit line to your scatter plot. I'm going to show you how to do these two things. This is extremely important. This is what you're going to have to be able to do on a test. I go into my chart and I go into Edit Chart. I go to Customize. And I'm going to click on Series. And notice that I can insert a trend line. For everything you do today, the trend line will be linear, meaning it will make a line. There are things such as trend curves. Now, here's the other thing we want to do. We've got the line, we don't see the R value, and we do not see the equation. If you click on label, you can say use equation, and it will put the equation up there. And finally, show R squared. Those are the three things you have to be able to do. Trend line, use equation, and show R squared. I'll click out of that, and we can see what we have, and I'll be able to go to the board. Anybody have questions how I came up with these pieces? We have an R squared of 0.746. We would say that that's a moderate relationship between the data. We have the heating bill, negative 1.68 times whatever plus 149. So we have our best fit line. You can see it's drawn that way. Anybody have problems how I came up with this? If you do, I will pause and come and help you. You guys good over there? Okay. Yes, we'll give you a second. All right, here we go. So please make sure that you have your screen available so you can help me out as I go to this part of my screen. It says find the correlation coefficient and equation for the best fit line. Instead of writing y equals mx plus b, I'm going to use y, which is your heating bill, so dollars is equal to, can somebody tell me what the equation was? Negative 1.68, what was it? Yeah, negative 1.68. Instead of x, I'm going to write T for temperature, plus 149. See how instead of using x and y, I use variables that map to what we have here. Everybody see that? That way I understand the x variable is temperature, the y variable is money. Everybody okay with that? Okay, then it says find the correlation coefficient. You don't actually have the correlation coefficient yet. We have R squared is equal to what? What was it? 0.746. So we don't want R squared, we want R. So what do we have to do to both sides? So we're going to square root 0.746. And I take the square root of 0.746 and I get 0.864. 0.864. True or false? R values can be positive or negative. True. Yesterday we talked about them being positive or negative. I want you to look at your graph. Is this R value positive or negative? It is negative because it is going down. So when you take the square root, you must then determine whether it's going to be the positive value or the negative value. So it is a negative 0.864. So I have my equation for my best fit line, and I have the correlation coefficient. So this correlation coefficient tells me that there's, reasonable relationship that exists among this data. Then it says predict the heating bill for a month in which the average temperature is 40 degrees Fahrenheit. So I want to predict the heating bill if it's 40 degrees for an average temperature. So all I have to do now is I can use this as a prediction equation. What would the heating bill be if the temperature was 1.68? If it was 40 degrees, we just type in 40 for the temperature. And then I just do that computation. So negative 1.68 times 40, and then plus 149. If it's an average of 40 degrees, we would say that the heating bill would be approximately $81.80. That's the great thing about correlation is you can make predictions then. It says, how accurate do you think your prediction is? Well, in order to talk about accuracy, we should look at our R value, 0.86. That's reasonably strong, isn't it? Yeah, I would say reasonably strong. Or reasonably accurate. I wouldn't say it's super accurate, but, you know, pretty good. That's the first example. We're going to do one more. Are we okay with that first one? Okay, and let's move on to the next one. Next one says, here's a number of teachers and students randomly selected, a sample of high schools in a city. So they went through a city and they looked at the number of teachers and students. Do you think there's a relationship between the numbers of teachers in a school and the numbers of students in a school? Which do you think causes it? Do you think that if you have more teachers that causes students to come on in, or do you think it's the number of students that then determines the number of teachers that they bring in? Yeah, so number of students is going to be the X variable, teachers is going to be the Y variable. So it says make a scatter plot using teachers as the independent variable. No, not teachers as the independent variable. Whoever wrote that was not thinking right. So using students. That should be the independent variable because the number of students will then determine the number of teachers that you have. So it says make a scatter plot of this data. So I'm going to go to my Google Sheet. And I will simply just, and you guys, you can continue to use the same Google Sheet for as long as you want. So I go to my Google Sheet. I'm going to go to Sheet 2, right click, and I'm going to rename it. I'm going to students and teachers. That way, if I ever want to reference it, the data is right there. Students, teachers. Nikki, can you be my volunteer? Can you read off the number of students so I can type them in, please? 1,050. 653. 753. 381. 1,312. 813. 496. 910. Is that it? All right, can you now tell me the number of teachers that they have at these schools? 92, 52, 114, 49, 110, 62, 76, 84. So, can you guys give me a general idea about this data? As the number of students increase, what would you expect to happen to the number of teachers? We would expect that. So if we don't see that on our chart, we might have some questions to consider. But it sure would seem like that is the situation. Okay? So here we go. I'm going to grab this data, and I'm going to insert a chart. It automatically picks the scatter chart, which is really nice. Let's check out this data. Could you draw a line through this data? Yeah. Do you think it's easier to draw a line through this data or the data from the first problem? Yeah, I think that this is a little bit spread out. And that may have some reasons. Some schools might have a low teacher-to-student ratio. Some schools might have a higher teacher-to-student ratio, depending on where they tend to allocate funds and also the different types of programs that they have. There's a lot that goes into that, okay? So let's go ahead, and we want to find what three things with this yet. What do I have to do? What do I have to come up with on this chart? Yep, edit chart. I'm going to customize it. I'm going to go into my series, and I'm going to plot my trend line. I need to make sure that I show that R squared value, and I need to make sure that I use my equation. Those are the three things that we need to make sure that we see there. You can see that the line is drawn. There is rhyme or reason to why that line is drawn in the way that it is. So it's not like there's 12 different lines that you can draw. There is just one best fit line. How that actually happens is a little bit involved. We don't have to know that in order to do statistics. We can just use this. So we see that there is a correlation. You guys said that as the number of students increase, the number of teachers should increase, and it looks like that is happening. You guys see the data. I'm going to go to the sheet of paper here that we're working on. I'm going to have you guys help me write this down. What is r squared equal to? Is it 0.461? 0.461. That's the r squared value. And then the equation for the best fit line, it's going to be the number of teachers is equal to, and what did we have for an equation? 0.0561. Okay, times the number of students plus what? 35.2. So that's my prediction equation. So it says predict the number of teachers in a high school that has 600 students. So, you know, somebody in the area might say, well, we're considering opening a new high school, having enrollment of 600. How many teachers would we expect to have? Some people might say 52 right away because it's close to that 653 number, 600, 653. But a better way to do it would be to gather that data, create the trend line, and then say teachers is going to be equal to 0.0561 times 600 students plus 35.2. .0561 times 600 plus 35.12. And I get 68.78. So that 52 is probably not the best number. So 68.78 teachers. Now, how accurate do you think your prediction is? Look at your r squared value. We're going to find r to find out how strong our data is actually related. I take the square root of 0.461, and notice I get 0.679. That's not as strong as the last one, is it? Yeah. So, how accurate do you think your prediction is? I would say somewhat accurate. I'd like to switch it up just for the last piece here so that we can see kind of last workings of how this would be. Suppose it said predict the number of teachers. I'm sorry, of students. If a school has 110 teachers. So suppose instead of predicting the number of teachers, suppose we want to predict the number of students. How do we solve this? Same way, but you put 110 in for T. So what you would have 110 is equal to 0.561 times the number of students, times the number of students plus 35.2. That can make a big difference. Not 0.561, but 0.0561. Thank you very much for catching that. So what am I going to do to solve this? What do I do? Subtract my 35.12. And then I'm going to divide the result by 0.0561. And notice you get 1,334. Oh, it's not? We're close. 110 minus 35.2 divided by 0.0561. There we go. 1333.33. So trend lines are valuable in making predictions, but we also like to consider the R value to see how good the relationship was. Why did I choose the positive value for R and not the negative value? Because it was trending up. That's that. You should have seen this, hopefully, a little bit in an Algebra 2 class at one point. But the fact is that we've had some kind of broken moments in our education over the past few years. But we will not just be dealing with trend lines. We're going to be looking at curves of different shapes. So what you can start doing is working then on these problems. Okay, so you got today. If you'd like to sit and visit with each other, you use your time however you want. If you'd like to start getting your homework done, that's the homework they'll be expected to hand in for this linear stuff. Okay. So the DVD, the camera, and the housing.